Hello and welcome to Learning Functional Programming with Rescript, Lesson 2. In this lesson, we're going to cover operators as well as something called tuples. The first type of operators that we're going to go over are our integer operators. You can think of these as the basic operations you do in math: plus, minus, multiplication, and division. And notice how we're talking about integer-only operations. We'll get into what happens when you try to combine integers and floats a little bit later. So let's start out with defining one integer. So let x be an int, which is equal to 5. So we can perform subtraction on this. Y is an int equal to 5 minus x, where y would be 0 after this operation. Y2 is also an int, where y is equal to 5 plus x. Y would be equal to 10 in this case. Let's do y3 is an int equal to 5 divided by x, where y equals 1 after this operation. And finally, y4, where it is 5 times x. Y is equal to 25 in this case. So these are integer operations. Notice how we don't have any decimals in here. We have distinct operators for floats. So our float operators are similar to our integer ones, but we include a dot after them to denote that they are operating over floats. So let's define x2, which is a float, equal to 5.5. And let's perform each of the float operations on this. So y5 is a float equal to 5.5. Notice how we include the dot after this, plus x2. And that equals 11. So let's do y6. It's a float equal to 5.5 minus x, and again we include the dot, x2 in this case, and then again we include the dot, and this equals to the float 0, which is not equal to 0. So notice how we always get a float back here. So let's do that for division. Where we get back 1.0. Finally, let's do a multiplication. So y8 is a float, 5.5 times x2, which gives us 30.25. The answer might actually be a little different from this because floats and multiplication are a little weird in programming languages. Sometimes it gives you a little bit extra, so it could be like 0.1, but for simplicity's sake, let's say this is 30.25. So we have our integer operators, our float operators. So what if I want to add two of these together to a float? Well, let's just try it for now. Let's see what we get. Not sure what we'd be expecting back here. Int maybe, float. Let's just go with int for now, and say x2 plus x. It's giving us a little error here. Oh, okay. So we're expecting an int down here, and we got a float back. Okay, so I know how to change that. Let's add a period here. Oh, wait. We're expecting a float now. So it seems like we can't do this. Let's just comment this out for now, and we'll get back to it after a little bit of history of Rescript. So Rescript was initially called Bucklescript, but the name was changed for branding purposes or something like that. And this is a little bit of a carryover as our standard library in Rescript, meaning all the functions we get for free just by using Rescript, is called belt, right? Belt associated with the buckle in Bucklescript. So let's go back to our earlier expression we were trying to write here. So we're trying to return an int in this case. So it'd be useful if we could convert x2, we want to use the plus operator in this case, and we can see it's taking in an int and going to an int. So it'd be useful if we can convert x2 into an int. Well, belt gives us something to do that. So x2 is currently a float. We go into the float module of the standard library, and we can do something called toInt, right? And so we'll do that on x2. Now, we lost some information here, right? We were using 5.5 earlier, and we're trying to convert it to something that has no decimal component. So the standard library just truncates the number, meaning it doesn't round, it doesn't do anything else besides entirely dropping the decimal point. So in this case, it converts x2 from 5.5 to 5. Even if x2 was 5.9, it would still convert it to 5. It's completely dropping the decimal component. So what is our overall answer here? Our overall answer here is 10. Likewise, if we wanted to let x4 be a float in the end, we can do x2, because it's already a float, our float addition, and then we need to convert x to be a float in this case. So it is currently an int, so we do belt.int, and then we do which function? To float on x. And this gives us a more correct answer of 10.5 because we're keeping the decimal component of x2. So let's move on to string operators. There's two major things we want to do with strings. We want to add two strings together, which gives us ++, or we want to do something called formatting strings. So we'll just write formatting for now, and I'll show you how to do that. So let's make a string called hello with the string hello. Let's say we want to create a new string that is hello world. So we want to do hello world. Well, we could just do hello world, but we're trying to learn something here. So let's do what we had already. The variable hello plus world. Now hello world is equal to hello plus world. So this is the resulting string in hello world. Finally, we can talk about formatting. So formatting in Rescript is similar to JavaScript in that we use backticks. This is called a backtick, and it's above your tab key if you have a QWERTY keyboard. And we can insert other variables into it by doing this special notation. So this is the variable hello world, meaning the string hello world. So we can even contain this specific string within a format string if we want. So this will give us literally that, whereas this will give us the hello world because it's doing variable replacement on here, whereas it's escaping this, meaning it won't care about what I do after this backslash. So this will give us the string hello world plus this little ditty at the end. So that's what our final output is for formatting. And you can play around with formatting a little bit more. It helps you display useful information to people. That is why we tend to do formatting. So finally, let's talk about the Boolean operators. So for those of you without a computer science background, there's various ways we can combine true and false answers to give us more complex answers. So let's let raining, which is a Boolean, equal false. It's not raining. And let summer, which is also a Boolean, equal true. So there are then various ways we can combine these together, and they are or, and operating on only one Boolean at a time, not. So let's say we wanted to say raining or summer. So we do raining or summer. And this is saying for the or operator, are one of my inputs true? Is it raining or is it the summer? And in this case, yes, it is the summer, so this becomes true. And so here is the truth table for, if we have true or true, we get true. If we have true or false, we get true. If we have false or true, we get true. And the only case where we get false is if they are both false. In the winter when it's raining, it is not raining or summer. So let's say raining and summer now is raining and summer. And the and operator requires that both inputs be true for its output to be true. So in this case, our output is false because it is not currently raining. So here is the truth table for the and operator. True and true gives us back true. True and false gives us back false. True, false, and true gives us back false. And false and false gives us back false. If it was raining and the summer, raining and the summer would be true. Otherwise, any other combination where one of those is false, or both of them are false, results in a false. So finally, the last operator we were going to talk about is not. So if we have not raining, not does the opposite of whatever's input into it. Is it currently raining? It's not currently raining, so that means true, because the opposite of false is true. And it has a simpler truth table because it's only one input and output. True goes to false, and false goes to true. We have less than, greater than, less than or equal, greater than or equal, equal or not equal. These last two can be used with most values in Rescript already to compare them if they're not equal or equal. So let's say we have some numbers here. So we have 5 equal to, which is an integer, equal to 5. We have let 6 is an int equal to 6. And then we have let 5 also equal to 5, which is an int. So let's do some comparisons on these and see if you can find the answer. So 5, 6. And the answer for this one is false, because 5 is not greater than 6. Let's do another one. This one's true because it falls into the case of 5 being equal to 6, and greater than or equal captures both of those cases. So if this was 7, it would also be true. Finally, let's do and this one is true because 5 is also equal to 5 also. The final thing we're going to talk about are tuples. Tuples come in handy when you want to stick two values together that have different types. So let's say we wanted to combine my x, which had a type of int from earlier, with my string hello world that had the value hello world as a string within it. How would I combine these two together? Well, our type system currently doesn't seem to be able to support this. We just have one type after our variables. So we have bools here, we have strings here. We don't have two types ever. So this is where tuples come in handy. So if I want to stick two different types together, I can say let my tuple equal, okay, we see some new notation here. We have parentheses. I'm going to declare what the type of the first part of this tuple is. It's an int. And the second part of this tuple, which is a string. And then I mirror this kind of declaration on the other side. I say, what is the int of my tuple? It is x. What is the string of my tuple? It is hello world. And this will compile down to 5 hello world. So within this tuple is actually this. We're just using variable names to refer to this. So how can I access each field of my tuple? So we do kind of the reverse of what we just did. We say, see how we put this into one thing earlier? We say, okay, take apart each part of this thing. So my int part, and let's say we don't care about the string part, we just do that. This means ignore that value. So my int part equals my tuple. If we point this at my tuple, we get int part equal to 5. Similarly, we can do ignore the int part and only take the string part of my tuple, and we get string part equal to hello world. We can do this, of course, in the same step if we'd like to. I'm just going to copy and paste this and rename the variables. And that in one step declares int part 2 and string part 2 equal to the values of 5 and hello world. So tuples are useful for transporting two distinct types around when you don't need a longer term solution. So this is just a quick way to transport two types around. And we call this a product type, where a product type is taking two distinct types, an int and a string, for example, and putting them together by combining them into one type. And we call it a product type because we can have both combinations here. We can have string as the first part, int as the second part, or int as the first part and string as the second part. So the number of output types is based on the different ways we can combine the input types. That's going to be it for today. We covered operators on integers, floats, as well as Booleans, and number to Boolean operators, and tuples. Thank you for watching.